So yeah, for question 15, point 21 from the homework, we have this 0.5 molar solution of pyruvic acid. Pyruvic acid is a weak acid. And then based on that, the pH of that solution is, what's your pH?
It's 1.84.
1.84. Based on information, right, we want to find what is the Ka of this solution. We know initial concentration, we know the pH. So our generic, right, Ka is going to be hydronium times the conjugate base all over my acid. I know the pH, so from pH, I can find hydronium, right? Hydronium is going to equal 10 to the negative pH. So my hydronium concentration is going to equal 10 to the negative 1.84. So I get 1.445 times 10 to the minus 2 as my hydronium concentration. That also is going to equal my conjugate base concentration. So Ka equals 1.445 times 10 to the minus 2 times 1.445 times 10 to the minus 2, because, right, my conjugate base is going to also equal the concentration of hydronium. It's a weak acid, so we're safe in assuming that my initial concentration is the same as my equilibrium concentration. So I'm going to square that and then divide that by 0.5. And I get a Ka for pyruvic acid of like 4.18 times 10 to the minus 4. Because we're given pH, we have 2 decimal places. I would report 2 significant figures. So I would say 4.2 times 10 to the negative 4 for my Ka value of pyruvic acid based on that. Right, we can make that assumption about 0.5 because it's a weak acid. So we don't have to worry about what goes into solution. And just say that whatever that value is, it's small enough that basically it's going to be the same as 0.5 at equilibrium.